Hey everyone, so we're going to start. The name of the talk is Unit Testing LLM Agents, and a little bit about myself. So I'm Adam. I work at a very, very small software company, one employee, called Wild Tree Industries, working mainly with NGOs here in Israel. I'm also a co-founder of the Public Knowledge Workshop, also known as הסדנה לידע ציבורי, for those of you who heard about it. And also, I'm an open data activist, working a lot around open data, and if you want to know more about me, you can find me on google.com. Okay, so we're going to talk about unit testing LLM agents. So the agenda would be, what are LLM agents? What is unit testing? How do we do unit testing for LLMs? And finally, unit testing LLM agents. So basically deconstructing and reconstructing that presentation title. So let's start with the first topic. What are LLM agents? And there are many definitions for LLM agents. In our context, we're going to talk about one specific definition, which would be natural language conversational interface. That is chatbot in a common language, which use tools and to fetch information or to perform all kinds of actions. So let's give an example. Imagine the good old pizza phone. You call and order a pizza. You tell them the toppings you want, tell them where to deliver it and how you're going to pay for it. Then the manager says, okay, I want to replace my nephew and replace it with AI. You know, AI is supposed to take our jobs, so let's start with this guy. So this is the new AI-enabled pizza phone. You have this interface. You converse with it. The interface asks you all kinds of questions about the pizza you want and how you're going to pay for it and where to deliver it. And finally, when it has all the information, it puts the order to the system, and the pizza is then made automatically and then delivered via like a robot or something. Okay, but we're going to talk about this LLM agent. This is the thing that sort of gets the information out of you and then finally puts the order in. So that's the LLM agent. Now let's talk about unit testing. And unit testing, it's not, we all done unit testing. It's not the integration test. It's not the system test. It's the white box test, like the testing the smallest unit of code. In our context, we want to see that the LLM agent actually works. So let's talk about the different parts of a unit test. We have the tested unit, the system under test. We have some input, we have some expected output. I was told I have to put some Python code here, so here's the Python code. We have this function, add returns a plus b. We have the test input 2 and 3, and we expect 5. Usually this is a bit simplistic. So the system under test is still a system under test, but we have some sort of scenario. We have a state validation, which checks that the state after running that scenario is something we expect. So for example, a more complex example would be append line to file. We have this function, we have this existing file, and we added to it a few lines, and then we make sure that the state after running the function would be the original data in the file, and then these two extra lines. Okay, so what is the problem of unit testing LLMs? And let's try to, I'll give a few examples, but basically LLMs are sort of a magic box. And these magic boxes are usually opaque to us. We don't know how they work. No one knows how they work. We can't sort of predict what they're going to give us. They're non-deterministic. They often give us different answers in different times. We can force them to be deterministic, but usually we don't want to do that because we enjoy the non-deterministic properties. But when we take this magic box and we integrate it into our software, we want to make sure that it works. Right? We want to write tests, not in a sort of let's evaluate the model kind of way. The data science guys do that. No, we have this pizza phone. We want to make sure that the pizza is being made according to the business logic and the business requirements. So this is a more classic way of looking at tests. We have this software component. We want to make sure that it works. So this is the context of the talk, not about evaluating and metrics and whatever, but actually writing the tests. So let's give an example of why this is problematic. So let's say we're integrating this LLM, and one of our scenarios is asking it what's the capital of France. It says Paris, great. Let's write the validation code. Output equals Paris. Awesome. Okay, now we run the test again, and it gives us a different answer. The capital of France is Paris. It's a valid answer, so let's modify our tests. Assert Paris in output. Great. Another test crushed. Okay, we have a more complex scenario. Name 5 major capitals. Great. We have a list: London, Tokyo, Beijing, Washington, Berlin. But then we run it again. We have a list of 5 other major capitals. What do we do now? Okay, no problem. We just need a list of all the capitals, and we make sure that at least exactly 5 of them are in the output. It's a bit of a bother to write that, actually. And for more complex scenarios, it's even more problematic. So what we're going to do, I'm going to use another LLM to test the test output. So let's take this, for example, this question and answer. So we have this question, name 5 major capitals. We have this answer, London, Paris, Berlin, New York, and Tokyo. And we give this question answer to another LLM. We ask it to evaluate the following question and answer for correctness, brevity, politeness, blah, blah. We call this LLM the evaluation LLM. And the evaluation LLM gives us a very nice, overly explicit answer. So it says, yeah, it's mostly correct, but there are some errors. Great. How we use it to know if the test passed? So we ask the LLM, please give us the answer as JSON. Success, true or false. This is what we use to know if the test passed. Score. How well, even if the test passed, it could have passed badly or great. And a reason. We have the reason because we want to know why the test failed, and also because just putting the reason makes the LLM think harder. So we put the reason. So this is the new output. So now it says, okay, success is false, score is 4. It gives us an explanation, and the test validation becomes these 2 lines. We just load the JSON and assert, assert for the success field, and if it's not true, then we give out the reason. So the test becomes very simple. We just need this magic box to tell us if the test passed. Okay, so what about LM agents? So the main difference with LM agents is that it's a conversation, right? So it's not just giving a question and answer and then evaluating it, but we have full conversation. So we need to navigate that conversation to a specific scenario. And as I said, we don't want temperature 0, so we know exactly what the LM is going to answer us. Let's give a few examples for scenarios. So we want to order a single pizza with pepperoni and mushrooms, or we want to order a pizza with olives, but then change our minds at the last moment. Or we want to order 10,000 pizzas. Or we want to order 1 pizza, but to the White House. So there are all kinds of scenarios, right? All of them, and some of them end up with this poor guy delivering pizzas to, I don't know, a mental asylum. So there are all kinds of scenarios, and for some scenarios, for example, let's say someone calls and talks about something that is non-pizza related, there are an infinite possibilities. So this becomes very hard to test. I mean, how do we write tests for all these weird scenarios? So now we introduce someone or something called the actor LLM. This is an LLM that basically pretends to be a human and is supposed to act a specific scenario, a specific test scenario. But that's just so you feel more connected to the thing. Okay, so each scenario has two parameters. It has the task, okay? That's the sort of the instructions to the actor. What do you need to do? You're supposed to be a user that just orders a regular pizza. You're supposed to be an annoying person. You're supposed to be someone who constantly changes his mind. You could just ask, the guy, what's the capital of France? This is the task. And then we have the desired outcome. What do we expect this conversation would result? Do we expect it to result in a pizza being ordered? Do we expect in the pizza not being ordered? And exactly the parameters of that pizza. So the actor only knows the task, and the evaluator LLM knows the task, but also knows the desired outcome. Okay, so for example, if we're testing a pizza phone agent, the task would be query about toppings available, then order pizza with 2 toppings. Desired outcome would be the agent should create an order for a single pizza with 2 available toppings. So this is the task, the thing that the actor should sort of act. Desired outcome is what we expect the entire test to result. Okay, so how would it look like in a Python implementation? So first up, we start by creating this actor LLM, give it the task. We create this conversation thread, and we start the conversation. We get the first message. This is sort of the actor starting the scene, right? And then we basically, we're basically just getting the response from the agent, sending the response to the actor. The actor gets a new message, and we're sort of communicating between them until the actor decides we're done. And then we take the entire conversation, give it to the evaluator LM. We get this JSON that we saw before. If it's successful, then great. If not, we have a reason why not. That's mostly the entire test code that we need is this one, and just also a list of tasks and desired outcomes. So how would the prompt for this actor look like? So first of all, we tell it, you need to pretend you're regular users. LLMs are assistants. They don't feel comfortable pretending to be users. So you're going to see we're sort of trying to force that behavior to that LLM. So you're to pretend you're a regular user, you're talking to an AI, only say sentences that a user would say, don't offer anything else, don't add anything else. I will provide the assistant responses. We ask it not to improvise. Don't try to invent anything. Don't try to, some test cases are supposed to fail, okay? And the LLMs don't feel comfortable when something doesn't work. So they try to sort of find a solution, or, you know what, that's fine, I don't want a pizza. No, you need to be very, very specific. Don't improvise. You need to allow it to be rude, to talk as a user. Don't be like the awful politeness that ChatGPT or all the other sort of are forced to talk. And when the assistant says goodbye, don't continue the conversation. This is very important because it needs to know when to stop. Okay, so the actor decides when to stop. We give it a sort of an end condition or stop condition, either when the scene is done, or when no new information is being provided, or when you're frustrated, or there's some kind of error, you must say stop. Otherwise, we get to a place where they both just say, okay, have a nice day, have a great day, I wish you best in your life, and it never ends. This is the you hang up situation. And I've seen it happen, so we need to be very, very strict on finishing. Finally, again, we need to tell the actor, behave and sound like a normal user, and here's your task. So after all this prompt, this is your task. And then the evaluator. Evaluator is simpler. We ask it to review the conversation. This is a conversation, be critical. This is the desired outcome. Make sure that it was achieved. Were there any mistakes, any misunderstandings? Was assistant helpful and efficient? And we can add, whatever we want to, whatever our goals or whatever our sort of business requirements are. And again, we ask it to provide a JSON. Was the outcome accomplished? What is the score? What is the reason? Even if all the tests pass, we can pass with a low score, and then we can work just to improve the score, right? So it's less binary than we're used to. Okay, yeah. And one final thing is leveraging temperature. So if we have, for example, a scenario where a user calls and talks about something irrelevant, we can run that test 100 times, and each time get a different conversation. And by doing that, we get a better coverage of that scenario, because again, the space of human interactions is infinite, or almost infinite. But we can get more comfortable with these sort of interactions if we run the same tests over and over again and get different conversations every time. I don't like this sort of probabilistic test coverage, but I guess that's how it's going to be from now on. Conclusion. So LLM agents are hard to test because they're non-deterministic, but we can use LLMs to test these agents. We don't have to use the same model, by the way. We can use a single, sort of a cheap model for the LLM agent, but a more expensive one for doing the tests or for the evaluation, because this is just tests. It's not like the production that has more cost implications. And the test results become non-deterministic as well. But rerunning the tests with variations can reduce the risk of surprises. That's it. And if you have any questions, go ahead.
Have you tried this in real-life scenario? And if so, where you said that this test is essentially stochastic. It's not a 100% foolproof test. Is there any benchmark on how well such tests perform?
I used it a bit, not in corporate production, because I'm not a corporate and I do less production stuff, but I did use this method quite a few times. And it's interesting because, again, you don't know exactly what's going to happen, but rerunning, it gives you interesting results. Also, in trying to understand the sort of what users would do, you get the conversations to go to all kinds of places.
Did you ever have any unexpected results? Like, for example, I don't know, you tell the agent or the actor what's the form of the JSON that it needs to have, and it fails in giving you the correct key in a JSON or something like that?
Yes, JSON is not usually, it had some problems generating JSON. I think now, specifically OpenAI has, you can force it to provide a JSON with a specific schema, so that's easier. But yeah, sometimes it just creates gibberish, and the test failed because of that. But you can run it again, run it 100 times. Even if it fails 10 times because of the bad JSON, then you don't care.
Would you let an LLM order pizza for real, like actually do the order? The LLM we have now, and what is the path forward you think so it can do it? One day it will do it, but what will be the kind of path forward?
So I think we're used to the concept of being able to get software to work 100% of the times, although it doesn't really, right? We always have bugs. But the question here is not if LLM can get to the same level as software. The real comparison here is, would LLM be better than that 16-year-old snotty teenager? And I think that in some cases, yeah, maybe. I've ordered pizza via the phone, and I know that it's not a 100% success endeavor. So I think LLMs, it's gonna make mistakes, but again, for businesses, I guess the question is how many mistakes compared to the minimum wage workers that they're gonna bring instead.
Once you deem a test and an actor stable, how often do you figure that you get a false fail or a false positive in your test?
So that's a question about the evaluator, actually. So the evaluator seems to be I would say the simpler component here, but the evaluator also wants to make sure that you feel good. And I've seen, for example, why do we need the evaluator? We can ask the test, the actor, if the outcome was achieved. And in many cases, the actor would say yes, even if the test failed, because it doesn't want to sort of disappoint the user, right? Because these are, the LLM models are terrible. But so they want to disappoint you. So it says, yeah, sure, the test passed, of course. And the evaluator also sometimes wants sort of to tell you, yeah, everything is great. So you need to work on the prompts and always have a human sort of sampling the results and making sure that there's like the actual result or the actual evaluation matches what a human would say. So you need some sort of human eye, just sampling and making sure that it works according to plans.
Looking at this probabilistic coverage, at what point do you say, okay, I tested enough cases that I'm quite sure that it's going to work okay?
I guess the answer to that is whether you're delivering pizzas to residential homes or delivering, explosives, right? So you need different levels of confidence in different scenarios. So that's more of a business question. It's the same as asking, how many QA engineers do you need, right? Or what sort of test coverage do you need to like code coverage do you need to be perfectly safe? Okay, thank you very much.